Hi, everyone. Welcome back to this FY22 CINR webinars. We are going to go ahead and proceed now with Workscope RC1 and with Janelle Edens from DOE-NE. Go ahead and take it away, Janelle.
Sure. So hi, everyone. My name is Janelle Edens, and I am the Federal Program Manager for the National Reactor Innovation Center, or NRIC. We also have on the line Bradley Tomer from INL, who is the COO for NRIC, and Brad will be available at the end of the presentation to help answer any questions and to provide additional information as needed. Next slide, please. Okay, so this first slide discusses the NRIC mission and goals. And NRIC is a relatively new program which was formally established in 2019. And the mission of NRIC is to enable and accelerate the development and demonstration of advanced reactors by using the unique capabilities of the DOE National Lab System. And NRIC has two primary objectives. The first is to enable demonstration of at least 2 advanced reactors. And we have set an internal goal for ourselves to achieve this objective by the end of 2025. And NRIC plans to meet that first objective by enabling access to infrastructure, sites, materials, and expertise. And one key activity to support this area is the development of a resource network. And with that resource network, NRIC has compiled information on all of the research capabilities that are available at the various national labs to support advanced reactor development. And through this network, NRIC is able to connect advanced reactor developers with the right contacts at national labs to access those research facilities. NRIC will also pay for up to 200 hours per project to allow advanced reactor developers to gain access to national lab experts. We also provide regulatory support by helping developers to understand the DOE authorization process. And we've been working very closely with the NRC on a number of activities that will help to inform the licensing of advanced reactors going forward. Another key objective of NRIC is to prepare the DOE labs for continuing innovation to support advanced reactor demonstration. And one key thing that we're doing here is we're working to establish what we call demonstration test beds at INL. And these test beds will provide the infrastructure where industry can come in and build and operate their experimental reactors or small-scale demonstrations and obtain the data that they need to support their designs. In addition to establishing those test beds, we're also working to establish experimental capabilities that currently don't exist, but have been identified as being needed for advanced reactor development and demonstration. And one example of such a capability is the molten salt thermophysical examination capability, which will soon be established at INL. And finally, NRIC is led by INL, but the resources at other labs and DOE sites will really play an essential role to achieving the NRIC objectives. Next slide, please. So one key activity that NRIC is supporting is the Advanced Construction Technologies Initiative. And a challenge that continues to face nuclear projects is the cost and schedule for construction. So with the ACT initiative, NRIC is aiming to make nuclear construction faster and cheaper. And to support that goal, last month, NRIC announced a cost-shared partnership with a team led by GE Hitachi to develop and demonstrate 3 construction technologies that together could potentially reduce the cost of new nuclear construction by more than 10% and could also significantly reduce the time needed for construction. And those 3 technologies are listed here on the slide. The first is vertical shaft construction. And this is the best practice from the tunneling industry. And by using this technology, we could potentially reduce the amount of excavation and backfill that's required. And we could potentially save $50 million per project. So that's a pretty significant savings. The second technology is steel bricks. And this is a steel concrete composite that can be rapidly produced in the factories and then shipped to the site for fast installation. And by doing this, we can significantly reduce the amount of labor required on site, and subsequently we can reduce the cost and the schedule. And the third technology is really a combination of two technologies where we combine advanced sensors with digital twin technology to create a digital replica of the nuclear power plant to allow for real-time monitoring of the structure. And these three technologies can be applied to a variety of advanced reactor designs, and we hope that they'll be available to support reactor developers by 2025. Next slide, please. Okay, so the first Workscope RC1.1 is very closely linked to the ACT initiative. And I'm the federal POC for this Workscope, and Dr. Ashley Finan from the INL, who's the director for Enrique, is the technical POC. So with this Workscope, we're looking for proposals that will identify, evaluate, and develop methods or technologies that can significantly reduce the cost and schedule for nuclear construction. And some things we recommend that you could potentially look at are improved project management practices, the use of digital engineering, open architecture design, improved construction technologies, and improved manufacturing approaches. So on the previous slide, I included a link to the ACT Initiative website. I would definitely encourage you to visit that website and to familiarize yourself with that GE project to ensure that any activities that you propose are complementary to what's already being funded and not duplicative. I would also encourage you to clearly identify why your proposed activities are considered improvements compared to current practices, and to provide an estimate on potential cost and schedule savings. Next slide, please. So the second Workscope, RC1.2, is focused on environmental justice and equity considerations in siting energy or industrial facilities. And this is an area that's very important to the current administration and is a very top priority for DOE and for the Office of Nuclear Energy. And so public perception and the positive benefits to communities hosting projects such as advanced nuclear are very important to the success of that particular demonstration project, as well as the prospects for future projects. So with this work scope, we're looking for applicants to propose an approach to deployment that considers topics like what technology is being deployed, the geography, economics, social issues, etc. And the work scope is purposely very broad, but we did include some suggested areas of interest, which are listed on this slide and also in the FOA document. And there's not a lot of recent nuclear cases, so it's okay to look at other similar type projects in the energy or industrial sectors, but your proposal should clearly state how the proposed studies are relevant to advanced nuclear siting and how the information gained from those studies can inform the approach for siting nuclear projects. And we also encourage applicants to think expansively and to team up with multidisciplinary partners. Next slide, please. The third work scope, RC-1.3, is focused on using advanced nuclear for specialized applications. And again, I'm the federal POC and Ashley is the technical POC, but please note that the funding limit is $400K for this work scope as opposed to $800K for the other two work scopes. And the reason why this is a priority for NE is that new large electric loads can pose challenges such as grid congestion, which could potentially be addressed by the use of microreactors or small advanced reactors. And with this work scope, we're looking for proposals that identify high-value niche markets and applications for the use of advanced reactors. And some examples of niche markets could be maritime applications, electric vehicle charging stations, data centers, just to name a few. And again, we encourage you to think very broadly with your proposals, but we do list some examples of things you might want to consider, such as what the CINR requirements would be, what regulatory analysis would be needed, provide any type of details on the reactor type or the reactor size, what kind of operator and security staffing would be required, and things of that nature. And in preparing your proposal, I would encourage that you perform a literature review and take a look at activities being funded by other DOE programs to ensure that the applications and scenarios that you propose are not being supported or explored by other DOE programs. In particular, I would recommend that you take a look at the Microreactor Research Program and the Integrated Energy System Program to ensure that there's no duplication or overlap with your proposed activities. Next slide, please. So this slide just includes contact information for me, Ashley, and Brad. If you have any questions on Enrique, please feel free to reach out, but please direct any questions on the 3 Workscope to neop.inl.gov. I also encourage you to take a really good look at the Workscope descriptions in the final FOA because there may be some changes as compared to the current draft version. And with that, Brad and I can take any questions.
Okay, thank you, Janelle. I believe Bradley is here with us. I don't know if you'd like to open your microphone so we can make sure we can hear you.
Does that work?
Yes, I hear you. That sounds fine. Great. Okay, first question. It says, how is this reactor concept Workscope related to nuclear engineering fields? It seems it's more related to civil and industrial engineering and social sciences type of study. Could you comment on that?
Right, so the mission of Enrique is to, like I mentioned previously, to enable reactor demonstrations. And reactor demonstrations, it encompasses a lot of different fields, such as social sciences. For example, public perception, like the environmental justice scope, includes, that's something that we need to take into consideration. So in order to successfully demonstrate these reactors, it's going to take more than just nuclear engineering. It's really a broad field and a lot of different topics that need to be addressed. Brad, do you want to add anything?
Yeah, I would just say that, part of our mission is also to, commercialize, we need to bridge the gap between advanced reactors and commercial reactors. So to get there, all these issues have to be addressed. So siting, construction, reducing, whatever impediments there are to commercializing these reactors, we need to address. So we have a pretty broad scope, and I think that's why we are looking at some of these things.
At this time, we don't have any other questions. Let's wait just a couple minutes, see if any more come in. Okay, here's a new question. For RC 1.3, is analyzing effects of microreactors on electrical grids an interesting topic that might be of consideration under this work scope?
So I think that would probably be of less interest under this work scope because we're really interested in looking at what potential niche markets you could use microreactors and other small advanced reactors for. So we're not really looking at how we can improve or modify microreactors. There's actually a work scope with the microreactor program that's focused on that. We're more looking at how you can use those technologies to support these specialized applications. Brad, anything to add?
No, I think you hit it just right. We are looking for applications and things that are not being currently pursued. So,
right.
Like Janelle said, maritime would be a great application. Things that we don't want, in other words, we're not looking for hydrogen, et cetera. We need these applications to be something nobody else is looking at.
Okay, next question. Is there any interest in analysis of distributed electronic production systems as a complement to, for example, irregular solar and wind power production?
Brad, I'll let you take that one.
Yeah, could you just say it one more time so I could hear the first part of it?
Certainly. Is there any interest in analysis of distributed electronic production systems as a complement to, as an example, irregular solar and wind power production?
Yeah, I think that there is some interest there. You know, it depends on you know, the actual proposal, but I think there is some interest there. So complement, I think we even called out complementing renewables as one of the ideas.
Okay, thank you. Next question. Considering these broad scopes, can teams include researchers from non-NEUP universities?
Guess I'll throw that one to Drew, to the NEOP team.
One second, we'll get him on the line here.
Okay.
Researchers from non-NEUP schools.
I'm here, Janelle. Can you hear me?
So-
This is Aaron.
Yes, yes.
Oh, yeah. Thanks, Aaron. Go ahead.
Yeah, absolutely. You don't have to be on the any particular list or part of any particular group to be a collaborator. So any U.S. university would be eligible to be a collaborator or partner on an application.
Thank you.
And Aaron, to be clear, for the CINR FOA, there isn't a thing such as NEUP schools. So that would only be for the scholarship and fellowship requests for applications.
Right, that's right. Absolutely.
Okay, thank you. Next question. Would qualitative studies on how to define justice and equity in the context of advanced reactor demonstration and siting also be of interest?
Yes, I think that would definitely fall under RC 1.2. So that is something that we would consider.
Okay, Janelle, it looks like that's all the questions we have
Okay.
for this work scope. So thank you very much to you and Bradley.